A very good afternoon to all of you. So I'm Mr. Teow. Welcome back to my video. So today we are going to discuss the questions that being given in the last video on chapter 1, which are on area of sector and area of segment. And also today we are going to summarize this chapter, which is on chapter 1, circular measure. We are going to summarize this chapter in which this chapter is going to end, and the next video we are going to enter our chapter 2 on differentiation. So if you have any questions that you don't understand, please feel free to come back to us in this week, so that in the next week we are going to enter the new chapter for additional mathematics. Okay, so without further delay, we're going to recall back what have we learned in this whole chapter 1. So in the chapter 1 that we recall, before we learn chapter 1, we have learned only the degree. So in which this degree denote with symbol degree, but for radian, we will denote with symbol radian. And it's actually the angle value for degree, for radian, both are angle value. Between two lines, we have line 1 and line 2. And the angle here stands for the angle. So there are two formulas we learned for including length of arc and also the area. These two are the same formula as what we have for radian. So no matter it's degree or radian, we have this formula. Okay. So for calculator, your calculator will start with the initial display, which is on degree mode. Then in the top of your calculator, you have a D there, so it means for degree mode. However, when you want to change the value, the mode to radian, you will press the mode 4 times and you choose number 2, so that you can see in the top of calculator, you have a R here. So this R stands for radian mode. And after you use the calculator, each time you must clear the mode by press shift plus mode to clear all the mode after use, and all the fraction that you type, you must remember to come with bracket. This one you should remember until the end of additional mathematics. Okay, so now let us refresh or recall on what we learned last class. In the last class, we learned two things on area. So this one we learned the sector, and we also learned the segment. So when you have area of sector, it stands for 1 over 2 r squared theta radian. This is given in your exam. Okay, however, for area of segment, this formula area of segment is not given in exam. So this one you must remember or you must interpret by yourself. For example, when you have this sector, you want to find this segment. So the segment will be equal to sector minus triangle. So this is a sector and this is your triangle. So you want to remove the triangle, you can get this segment. So make sure every time when you change your calculator to radian mode, you must remember, first of all, place mode 4 times, place number 2. Make sure the top calculator it shows the R, and you calculate the answer. After you calculate the answer, you must clear the mode by place shift plus mode plus, and you choose clear all, so that it won't jeopardize or affect your answer after this. Okay, so now let us discuss the questions. This is the questions being given to you as your homework last week. So we are going to discuss these questions. First questions, find the area of a sector BOC. So we will highlight the important points. Sector BOC with diameter 10 centimeter. So remember this is diameter. And the angle at what? Oh, 1 radian. We are going to draw this. Okay, so we are going to draw this. First of all, we draw this sector. So when you draw this sector, you have an angle at center O, and this is sector BOC. So this is BOC, and then your diameter is 10 centimeter. So remember this is diameter. So diameter we denote with 2r. So diameter equal to 2r. So 2r equal to 10 centimeter. So from here we must first find the radius. So the radius is 5 centimeter. And we draw this here 5 centimeter. You have radian, 1 radian. So when you want to find the area, remember area of sector equal to 1 over 2 r squared theta radian. Then we replace one by one. So r is 5, theta radian is 1. So you will directly get your answer. So your answer should be 12.5 centimeter square. This is the answer for the first question. Alright. So for the second questions, you are given a radius 5 centimeter, area 15 centimeter square. So you want to find the angle at B. So first of all, you will draw the sector ABC. So you have sector ABC here, A, B, C. So when you draw the sector ABC, you will label the radius. So radius here is 5. You label it 5. And then the area, this is area of sector. So the area of sector is 15. So it means this area equal to 15. So now you are going to calculate the angle at B in radian. Then what you are going to do in radian, the first of all, you must recall the formula. Area of sector equal to 1 over 2 r squared theta radian. By replace the formula, you will get the answer. So the angle of sector is 15, and then you have r is 5 squared. So you want to find theta radian. So what you will get? You will get 15 equal to 12.5 theta radian. And you remove, you will get the answer. Theta radian equal to 15 over 12.5, which is 1.2 radian. Okay, and then the answer in radian is what you have in radian. So this is the final answer. Okay, these two are easy questions. Now we are going to enter the questions. This one a little bit hard compared to before, in which this figure shows the cross section of a cylindrical birthday cake. So cylindrical, if you still remember the formula of a volume of cylinder, you have volume of cylinder. Okay, so you have volume of cylinder equal to pi r square h. Okay, however, this pi r square actually you have another thing that being covered here. We will see this later. So given this diameter, okay, diameter, you will see here diameter is 16. So when you need diameter, you don't need diameter. So we are going to calculate the r. So from diameter equal to 2r equal to 16. So r equal to 8 centimeter. Okay, and then your angle, okay, the angle at O is 1.2 radian. So we will write here angle at O is 1.2 radian. Okay, you are going to find the volume of the icing needed to cover the surface of the cake. If the cake is to be made with 1 over 10 of part of icing, the rest are none part of non-icing. Okay, we want to calculate icing. So you will write here volume of icing. Okay, volume of icing. If you still remember, every time okay, you see cuboid here. So when you want to calculate the volume of cuboid, what do you do? Okay, let's say your cuboid is like this. So we will first calculate this surface, which is a square, and then you multiply with this width. Okay, so if you turn this around, you will see this is the height. Okay, so same theory you will use for this one. So the first is the surface. So by calculate the surface, you are going to calculate the surface. So the surface here is the area. So we are going to use the area of sector formula is 1 over 2 r squared theta radian, and then you multiply with the height. Okay, for icing we have only 1 over 10, so we are going to calculate 1 over 2. You have radius, which is 8 squared. You have the theta radian 1.2 radian, and you have the height, which is 1 over 10 times 15. So by this you will directly get your answer, in which your answer is 57.6 centimeter cube. Okay, because this is the volume. And you must remember to put all the bracket here, 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 and here. Okay. Okay, and then next, this is what we learned last time on the segment. All right. Okay, so the questions on the segment, we are going to see how we are going to calculate the question. So this is the first question of the area of segment, in which as your homework in the last video also. So we are going to discuss this. Okay, first you want to find the area of a minor segment for a sector with a radius 10 cm at center O with angle of 1.3 radian. Okay, so if you cannot see your segment, you must draw out this segment. So we will draw out this segment. This is your sector, and then this is center O, and you have the segment. So this is the segment that we want. Okay, so we are going to calculate radius is 10, and you have 1.3 radian here. Okay, so first of all, we will look up this formula, area of segment. So area of segment equal to area of sector minus area of triangle. Why minus area of triangle? Because we want to take this big sector. I will draw this one in black color. So you will take this big sector. Okay, you take this big sector, you minus this small triangle. Okay, so you will take this big sector, you minus the small triangle, so that you will get the segment that you want. Yeah, I hope you can understand. Okay, so now we are going to calculate one by one. So for area of sector, we'll have 1 over 2 r squared theta radian. For area of triangle, you have 1 over 2 AB sine C, or here is R times sine theta radian. Okay, so this one, remember, change your calculator to radian mode. Okay, we are going to calculate one by one. So the first of all, what is your R? Your R is 10 squared theta radian 1.3 minus 1 over 2. R is 10, R is 10, and you have sine 1.3 radian. Okay, so what is your final answer? Okay, for the first one, the area of sector, you should get 65. And then for area of triangle, you should get 48.18. So you will get the final answer 16.82 centimeters squared. Okay, this is the final answer for this question. Okay, for the next question, you given the area of segment is 12. So this is 12. Find the radius of the sector if the angle at the center is 0.5. So as the first, we will draw out this sector. So this is sector, this is segment. Okay, so remember this segment, you have area equal to 12. Your radius is unknown, which one you want to find, and then you have 0.5 radian here. Okay, so the same time we are going to put formula. So area of segment, this formula equal to area of sector minus area of triangle. Okay, so we are going to build this formula. The area of segment is 12 equal to area of sector 1 over 2 r squared theta radian minus 1 over 2 r times sine theta radian. So at the same time, this one you need to use the radian mode. Okay, we are going to calculate this one. So 12 equal to 1 over 2. You have r, which is r that you want to find. Theta radian is 0.5. 1 over 2, r times r is r squared. And then sine 0.5 radian. Okay, so from here you will get your answer. So the first part you will have 0.25 r squared minus second part is 0.2397 r squared. So 12 equal to 0.0103 r squared. So you will get r squared equal to 1166.49. Okay, so you will get a final answer r equal to 34.15 centimeter. Okay, so this is the answer for this question. Okay, for this question, this is another high order thinking skills question. So the diagram shows the cross-sectional design of the container. So the cross-sectional design of container is in circle shape. Given that your radius is 10 centimeter, angle AOB is 1.2 radian. So we are going to draw what is radius 10 centimeter. So this is radius. Okay, this is radius. I should draw with dotted line. Okay, this is dotted line. So this is 10 centimeter, and you have angle AOB. So AOB, the angle is here 1.2 radian. Okay, so the first question, you want to find the length of the mouth of the container. So where is your length? Your length is at this place. Okay, so how we are going to calculate this? First of all, we will move out this triangle. So this is your triangle. Okay, your triangle is like this. So this is A, this is O, this is B. You have 1.2 radian, you have 10. So every time you must draw. Okay, if you cannot see, you must draw it out. So from here, we are going to calculate this one. So how you are going to calculate AB? Okay, we will see one by one. So first of all, you draw dotted line. So you can see this is a right angle triangle. So we are going to calculate this one. First of all, you have 10. So this is also 10. Okay, you want to calculate this one. Okay, you can see here we have two same or similar portion. So it's actually AB over 2. So this is your, you can see here, this is AB over 2. Okay, if you cannot see, you must label. Remember, always label. Okay, so now we are going to calculate this one. So you can see this triangle, you use the trigonometry. Okay, so you use your trigonometry. When you have an angle, you want to find the angle. Okay, if you want to, you have an angle here. Okay, this angle you can see is opposite over hypotenuse. So you are going to use sine. Okay, so we will do one by one. Okay, first of all, you will use sine. Okay, sine what? Sine 1.2 radian over 2. Why over 2? Because we have two same angle here. So it will equal to opposite. So what is your opposite? Your opposite is AB over 2. Your adjacent, your hypotenuse is 10. Okay, so you are going to calculate this one. So we will do step by step. Sine 0.6 radian equal to AB over 2 over 10. And then you will calculate sine 0.6 radian. You must remember this one use radian mode. Okay, make sure you have your R in your calculator. So sine 0.6, you will get, okay, sine 0.6, you will get the answer as 0.5646 equal to AB over 2 over 10. So you will use your AB. So what is your AB? Your AB is 11.29 centimeter. Okay, so this is the answer for the first question. Okay, for the second question, you want to find the area of the cross-sectional diagram of cover only. Where's your cover? So this is the cover. Okay, so this one will be easy question. Why easy question? Because you have already get what you have from question I. So now we are going to calculate this area of cross-sectional diagram by using area of segment. Okay, you know this is segment. So area of segment equal to area of sector minus area of triangle. Okay, so area of sector is 1 over 2 r squared theta radian. Area of triangle 1 over 2 r times sine theta radian. So what you get? You get 1 over 2 times your r is 10 squared. Theta radian is 1.2 minus 1 over 2, 10 times 10 sine 1.2 radian. So you will get your final answer. The final answer is 13.4 centimeter squared. So this the process in the center you calculate by yourself using the calculator. So remember this one you need to change to radian. Alright. Okay. So for this question, this is the exam-based question as a homework also, question number 7. So from here we are going to calculate one by one. The first question, they ask you to show the angle RS equal to 1.287. So where is angle RS? R is here, O is here, S is here. So this is angle RS. Okay, how we are going to show this question? Okay, first, okay, what we do, first you must draw out this triangle. That's what I can say. You cannot see, you must draw out triangle. So I will label R O S. Okay, so you have OR. So what's your radius? Your radius is 10 centimeter. Okay, and then you have PU equal to RS. So this is 12 centimeter. So we are going to calculate this angle. So what angle you are going to use? You can actually use cosine rule that you learned before in the solution of triangle, or you can use trigonometry. I would prefer use trigonometry. Okay, so if you use trigonometry, you would divide this by half. Okay, so as what you can see, first of all, we are going to see this triangle only. I will draw in black color. Okay, this triangle is the one that we want to see. Okay, so you have a 90-degree here. Okay, so your step one is you use this angle. Okay, what angle you have here? This angle is actually angle ROS divided by 2. Okay, angle ROS divided by 2. So you will see this and this. So what is this? This is opposite. This is hypotenuse. So you use sine. Okay, so you are going to draw, you are going to build this equation. So you have opposite, which is 12 over 2, and you have hypotenuse, which is 10. So you are going to calculate one by one. First of all, you have sine angle ROS over 2 equal to 6. Okay, this is 6. This one is 6. 6 over 10 is 0.6. So we are going to calculate ROS over 2 equal to sine 0.6. Okay, remember you want to find what? You want to find radian. So change to radian mode. Okay, you change to radian mode. You place at sign. You know how to place at sign. Okay, you place at sign by place shift plus sign. Okay, you will get the at sign. So you place at sign 0.6. You will get the answer. Okay, what is at sign 0.6? At sign 0.6. You will get the answer in radian. Okay, and then you place this answer, you times 2, you will get your that degree or your angle RS equal to 1.27 radian, and you put it as shown. This one must write, okay, because you already shown here. Okay, so you are already shown here, you will write a shown here. Okay, for the next sub question BI, we are going to find the perimeter. So when you want to find perimeter, you will see this metal plate. So it's a metal plate. Metal plate is this one, unshaded region. Okay, you want to find unshaded region. So what you're going to do, you're going to draw the line that we want. Okay, so you want to write, okay, first of all, build equation. Okay, what is the perimeter you want to build? Perimeter is equal to PU plus US plus SR plus PR. You have 4 lines here. Okay, I will draw for those who cannot see. You can see here this line 1, this line 2, you have line 3, and this is the last line that we want. Okay, and then you are going to calculate PU. Okay, what is a PU? Okay, your PU already being given in question. PU equal to 12 centimeter. And then you calculate US. Okay, what is US? US is this place. Okay, if you cannot see here, this US you have dotted line. So you can see there's one sector. Cannot see, draw it out. Okay, so you have this sector. Okay, what you have here, you have 1.287 radian that you get from question number A, sorry. Then you have 10 here, you have 10 here. So you want to find this arc. So remember formula of arc, S equal to R theta radian. So we will calculate this one. US equal to R theta radian. What is your R? Okay, your R is 10. Theta radian is, okay, remember 2 pi equal to 360, pi equal to 180. This is half of your circle. So half circle, this is half circle. So half circle is pi minus, half circle is half pi. Okay, so you already have 1.287 here. So what is this? This is minus 1.287. Okay, so you will get your answer by calculator. You press calculator, 10 times pi minus 1.287. You will get your answer. So your answer for this question, you should get the US, which is, you should get your US as 18.55. Okay, 18.55 centimeter. Okay, and then you will see SR. So what is SR? SR is same as EU, so also 12 centimeter. Okay, it's also 12 centimeter. And then you will see PR. So PR actually equal to US, which is 18.55 centimeter. So by adding all this, you will get your perimeter. So perimeter equal to 12 plus 18.55 plus 12 plus 18.55. So you get your final answer. So the final answer is 61.1 centimeter. Okay, so this is your final answer. Okay, for question B2, we are going to calculate the area. Okay, same thing. So this area is the unsettled region. So we are going to calculate this area. You can see here, because we build our formula, area of the metal plate is equal to area of this circle minus area of segment. Okay, we are going to calculate one by one. First of all, area of circle. So area of circle, you have the most easy formula, pi r squared. So you have pi times, where's your r? Your r is 10 squared, so it's 100 pi. Okay, or it's 314.16 centimeter squared. Okay, and then you calculate area of segment. So area of segment equal to area of sector minus area of triangle. Okay, so we'll build formula, area of sector as 1 over 2 r squared theta radian minus 1 over 2 r times 5 theta radian. Okay, so we will substitute into formula, 1 over 2, your r is 10, your theta radian is 1.2x7, you get from number A, minus 1 over 2 times 10 times 10 times sine 1.2x7 radian. Okay, so you will get your final answer. Your final answer should be 16.35 centimeter squared. Okay, this is for one segment. Okay, remember this is one segment. Okay, we have two segments here. So what is your area of metal plate? We will continue here. Area of metal plate equal to 314.16 minus 2 times 16.35. So you get your final answer. The final answer is 281.46 centimeter squared. Okay, so this is the final answer. Okay, so now we are going to enter the life of circular measure in our daily life. Okay, what application of circular measure in our daily life? First of all, it can be applied in anything with circle shape as long as we have circle. Okay, so some of the application you can see from here, you have rainbow. So you can see this is circle. I draw the circle part here. Okay, this is circle part for rainbow. You have tunnel. This is the circle part for tunnel. Okay, this is your cake. Okay, this is what we see in the examples before. You have the cone here. Okay, so you have four applications, and there are other applications which we will see along when you answer the question. Okay, there are summary of chapter 1. We will summarize this whole chapter. So chapter 1, we want to convert from degree to radian and vice versa. Remember, theta radian equal to theta degree times 2 pi over 360 because this is less than 1. This is bigger than 1. Okay, and then second part, you want to calculate arc length. So S equal to R theta radian. Calculate the area of sector. You have these two formula. This is given in exam. This is given in exam. This is not given in exam. And there are other skills for you to remember. There are trigonometry, there are perimeter, there are area and volume of the shape related to circle. Like your cone, you have cylinder. Okay, now we're going to enter one question. This is another question from the old syllabus, but it's also related to circular measure. We will see this question. This is quite hard question. So we are going to look into this question, and then I will leave the other questions for you as homework. Okay, so we will see diagram 11 shows a piece of decorative material to make a necklace. That the material is formed using sector AOB. This is sector AOB. AOB. Okay, and then the semicircle BDC. So I will use another color. This is semicircle BDC. Okay, so the radius of both are 1.5. So we cannot see, you must draw it 1.5 here. Okay, so you can see clearly. Okay, sector AOB is blue in color. So this is blue in color. Semicircle BCD is gold in color. So this is gold in color. This necklace, you will need 5 pieces of this decorative item. So you need 5 pieces of this whole decorative item. Okay, the raw material to produce is 210 centimeters square each. Alright. Okay, so like this given a piece of raw material. So raw material you have blue 210, you have gold also 210. Okay, so you will see how many piece of necklace you can produce. Okay, first of all, we will see one very informative thing, which is one necklace. You will use 5 pieces of item. Okay, and then you have one piece of item with blue and gold. Each you need one. Okay, so we will calculate. First of all, we will calculate the area of the blue region. Okay, what is the blue piece that you need? Area of the sector equal to 1 over 2 r squared theta radian. This one I will only write once. Okay, and then we calculate area of BOA or AOB equal to 1 over 2 times 1.5 squared times theta radian. What is the theta radian? Your theta degree. Okay, theta degree, you want to change to theta radian. So you will find what is this. Okay, this one is, remember this is a straight line. So the angle on a straight line is 180 minus 72. This is degree. Okay, you want to change to radian, how you do? Theta degree is bigger than theta radian. So you times with 360 over 2 pi. Okay, so you will get your final answer. What's the answer you will get? Okay, the answer you will get for this one is, okay, the answer you will get in this one is 2.1204 centimeters squared. Okay, and then another one you want to calculate angle of BCD. So angle of BCD is 1 over 2 times the same thing, radius 1.5. You have the pi. Why pi? Because half of a circle is a pi. So you get the pi radian. Okay, so the answer is 3.5343 centimeter squared. Okay, up to here you will get your answer. Okay, you will see how many pieces of blue we have. Okay, how many pieces of blue you can get. Okay, for blue one you can get 210 over 2.1204, which is 99, around 99 pieces. Okay, for the gold you have 210 over 3.5343, which is around 59 pieces. Can you make a 59 pieces plus 99 pieces? No. So maximum of blue can only, okay, will write here, maximum, okay, maximum for blue should be equal to maximum for gold, which is 59 pieces. Okay. However, one necklace only 5 pieces. So what? How many necklace you can get? Okay, maximum necklace you can get is 59 over 5, which is around 11. Okay, so final answer is 11. Okay, the next question, this is for your homework. Okay, homework number 1, because we don't have time to finish this. Homework number 1, diagram 3 shows 2 circles with same size, each one with radius 6 centimeter. Okay, you touch other in the outer part. So this is, you remember, this is a tangent. Okay, you use a tangent. So this one you use the angle rule on tangent. Okay, so both of circle touch the inner part each other with center O. So center O is here, and then you have radius 18 centimeter. Okay, so 6 centimeter is a small one. This one 6 centimeter. Okay, so first question, you want to calculate the perimeter of the shadow region. All right, and then The second part, you want to calculate the area of the center region. Okay, for this question, I will give you a hint. So by using this one, you should first of all connect these two center. Okay, by connecting these two center, and then you're connecting with this one. Sorry, you will connect with this one and this one also. Okay, so this is 90 degree, this is 90 degree, and you will connect this one. All right, then you connect this one here. This is 90 degree. Okay, this is the first hint that I will give. So you will continue answer this question, and you can get the answer in the link of material that I will attach later. Okay, this is the second question of your homework also. Okay, so in this diagram, you have actually the length of arc 1.5 times of the radius. So you calculate AOB in radian. Okay, and the second question is you want to calculate this one. Okay, so you want to calculate AOB in radian also. So these are all of my uh, video, and then for this chapter 1. In the next week, we are going to enter the chapter 2 on differentiation. So if you have any question on chapter 1, you can come back to me at any time that you want. So that's all from me. I'm Mr. Teow, and we'll see you in the next video in the new chapter. Thank you.